if you have questions, what? Okay.
I can't finish.
It's easy.
I will get
And that has a remainder.
I got 2x.
I had questions.
So that's 1, 2, remainder.
Just everybody, yeah? Yeah.
Infinite.
Infinite.
I got it wrong.
Got it? Okay, can you listen? Hey, listen. So, 5H was difficult for lots of people, everybody. So I'll do that in the tutorial later today. Okay, 5H. But as you can imagine, I don't think it'll be that difficult in the exam. And if everybody found it difficult, maybe there's a mistake in the question too. Possible. Or the answer. Yes, either way. But apart from that, was there any other problems from the previous two exercises? Which one? Discriminant. Yeah, which one? That last one there. Yeah. So I'll do that one later in the tutorial today. Anything else?
And how to confirm its linear algebra to E and
Oh, the factor or not? No, that's not what I'm asking. I'm asking if it's a factor or not. I'll do that one later in the tutorial, okay? Okay, so it seems like there's some small problems in the last two, but I'll take care of the tutorial later today, okay? So if you turn to page 34 now. Remainder theorem, yeah. Okay, so, listening? The remainder theorem. And before I start, Hamish, come on, I've looked over there twice now, come on. Before I start, someone will ask me if they need the proof of this for the exam, okay? You don't need the proof for the exam. But the proof is nice practice. It's good practice of long division. Okay? So yes, you don't need the proof for the exam, but the proof is excellent practice of long division. Okay? So to start, fx is ax cubed plus bx squared plus cx plus d. And what's the name of this type? What's this one called? Well, yeah, but the power 3 here. Cubic. Okay. So we want to divide this cubic by, let's say, x minus k. Now the reason I haven't put any numbers in yet is because what I'm trying to do is find a formula for the remainder. So what I'm going to do is I'm going to do long division, see what I get at the end as my remainder, and that's my formula for the remainder. So in future, I do not actually need to do long division. Okay, so what I'm trying to do here is find a formula for the remainder. That's why there are no numbers. Okay, so we'll do the long division. I haven't even started yet. Now, what would I need first for this division? What's going to be the first term?
AX squared.
Yeah, ax squared. Ax squared. So when I multiply here, I get ax cubed minus ak x squared. Is that okay so far? Yeah? I'm just multiplying by ax squared first, so I get ax cubed minus akx squared. So I subtract, and here I have bx squared minus akx squared. So in total, how much would I have? B plus ak x squared. Now, it's a little easier if you think of them as numbers, isn't it? This is like, for example, 3x squared, and then this one is like minus 2x squared. So what would you do? You would do 3 minus 2. It's just a little more difficult with letters, that's all. Okay, so we'll scroll down a bit. Right. What do I need next? B plus ak x, isn't it?
Yeah.
So when I multiply b plus akx by x, what do I get? Oh yeah, I should carry those down. I get b plus ak x squared minus bk plus ak squared x. And let me just explain that one if you can't see it. See the second one there, b plus ak x times k. I put the k inside the brackets. So that's why I have bk and k squared there. Okay, so if you want, you could have left the k out in front here, and it went k multiply b plus ak x. Could have left the k out there. I just put it inside. Okay. So now I subtract. So these cancel. Now, sorry, that's a c there. So I need big brackets here. C minus minus, so that's plus. C plus bk plus ak squared x plus d. I'm subtracting these two, so if you look, it's this one, cx minus minus all of this x. So that goes together in one here.
So it becomes positive.
Does it all have composite?
And became positive, yeah, because the minus, you're subtracting the lines.
Okay, if it was negative.
Oh yeah, if this one here was positive? Yeah, so then it would just, these two signs here would be negatives. Yeah, okay. And lastly, what do I need up the top here? I would need all of this again, wouldn't I?
Yeah.
So I get C plus BK plus AK squared. So I multiply and I get C plus BK plus AK squared x minus, and I'll multiply the K in, CK plus BK squared plus AK cubed. And again I subtract. Now, I know that this is the end of the long division because when I divide a cubic by a linear, what's the result? Cubic divided by linear? No, quadratic. And what do I have up the top? I have a quadratic.
Yeah.
So this is the last subtraction I need to do. You can see. So down here I would get D minus minus this, so I'd get D plus plus CK plus BK squared plus AK cubed. What's this piece at the end called?
Remainder.
remainder. So here's my formula for the remainder. Let me rewrite it for you. Remainder equals AK cubed plus BK squared plus CK plus D. Does that look familiar? Should look a little familiar.
Oh, that's the first equation.
It's the original, isn't it? Except for one difference.
X is K.
Yeah. So it's the original, except here, the original here, except X is K. So this gives us a very, very, very convenient formula. The remainder equals FK. Now, I'll explain what that means now in an example, but that's the result. That's the remainder theorem there.
What is K? Constant?
Yeah, I'll explain with an example, but it's a number, yeah. Yes?
So I didn't understand what you did before you found the R. The remainder.
Here?
Before that.
Here?
This step, yeah.
Oh, I just subtract the two lines, and this is what I got left at the end. So you know when you do long division, the number you get at the end is the remainder. Yeah? If this is the end here of the long division, and this piece here is the remainder. Yes? Now can you go check your notes, and can you check for the first example of long division I gave you, and tell me what it is. Can I scroll down?
6 X squared plus 13X squared.
Here, let me just write it here. So you can check if this is right. I said 36x cubed minus 59x squared minus 25x minus 2. Does everyone have the same one? Yes. And what did I ask you to divide by? X minus 2. And what was your remainder? 0. The remainder theorem says you can calculate the remainder by replacing x with 2. So take out your calculator and see what you get for this. Go check. Zero. And what did you get as your remainder for long division? 0. See? Same answer. So that's how the remainder theorem works. You need to be careful. Let me point out some things to be careful about. If here it's minus, you put in plus, and vice versa. So if this was plus 2, here would go minus 2. And then what about if I ask you to do something like divide by ax minus b, if there was a number in front of the x?
B over A.
Very good, b over a. So the remainder is fb, if there's no a, or fb over a, if there is an a. So it's going to be one of the two. When you write it in this form, what is this called? What does this look like when it's written in this form? Yeah, not quite function. It looks like a factor. Yeah. And then when you write it in this form, this one, root, yeah. Okay, so that's why this minus becomes a plus. It's when you change it from a factor to a root. It's a similar idea. And if the remainder is 0, what is it called? It's called a factor, isn't it? Yeah? If the remainder is 0, remember?
Then it's a factor.
It is a factor, yeah. So I'm calling this a factor, but I don't really know yet if it is a factor. It just could be a factor. We'll have a look at some examples now. Can I scroll down? Yeah? Okay. Yes? Alright, so let's have a look at some examples. So first example is just question 1a. I ask you to change the factor into a root. So if this is a factor, what's the root? Very good, yeah. 1 over 5. Can you see how you do that? In your head, you say 5x minus 1 equals 0, and you rearrange it. The 1 goes to the right and the 5 goes down. So you get 1 over 5. What about this one? 9x plus 7. What's that one going to be? Yeah, minus 7 over 9. It's just a little practice of changing between the two. You look a bit confused. Yeah. Which one or both? Here, let's take this one. Imagine it equals 0. So what's x? What do you do first?
Minus 6 over 5.
Yeah. Nailed it. Okay, and then the next example is converting backwards. So if I have 5 over 3, 3x minus 5, good. And then we'll do one more, minus 8 over 5, 5x plus 8. You're just doing it backwards. Okay, can I scroll down? Yeah, okay, so now on to an example where we actually have to use the remainder theorem. So, this is question 3. I have 18x cubed minus 71x squared plus 28x minus 1 divided by 2x minus 7. So if I want to use the remainder theorem, what do I need to do first? Yeah, so I need to change this here into 7 over 2. And then what do I do with the 7 over 2? Replace it. So I get 18, 7 over 2 cubed minus 71, 7 over 2 squared plus 28, 7 over 2 minus 1. Okay, check that on your calculator. What is it?
Minus 1.
Yes. Okay. I'd like people to try the next one for me. 25x cubed plus 5x squared minus 56x minus 1 divided by 5x minus 7. Okay. Try that for me. I want to know what the remainder is. Minus 1 also in this case. So do you see why the remainder theorem is so useful?
Yep.
you can get the remainder much quicker than by using long division. Right, let me see how much you care. Alright, let's look at a more difficult example now. Yes. Can I scroll down? Okay, so now this will be like number 4A. Find P if x minus 3 is a factor of 2x cubed plus px squared plus 21x minus 18. Okay, so let's look at the information we know. If I'm telling you it is a factor, then what do I know about the remainder? The remainder is 0. So me saying it's a factor is saying that the remainder is 0.
Everything should be
Yeah, well, after I do what?
after the case.
Yeah, after I replace x with, what number do I use for x? 3. If I put x equals 3 into this, what should I get as my answer? 0, because the remainder is 0. So I have 2 3 cubed plus p 3 squared plus 21 times 3 minus 18. That should equal 0 because that's the remainder. Okay. What's that? 27. Is that 54? Can someone check? 54 plus 9p plus 63 minus 18 equals 0. So p would equal 18 minus 63 minus 54 all over 9. Is that right? I'm taking the 63 over, it's minus, take the 54 over, it's minus, take the 18 over, it's plus, and the 9 goes under. Yeah, what's that, so? What is it?
Minus 11.
Minus 11. So P is minus 11. You might get this question as a section A question in the exam. I'll give you one to try, but there's a longer example that's quite common as a section B question. So before we do that, I just want you to try one for me. So, another example here. When 3x cubed plus 15x squared plus 20x plus p is divided by x plus 1. Sorry, I don't want to mix them up. Oh, sorry, x plus 3. 3x cubed plus 15x squared plus 20x plus p is divided by x plus 3. The remainder is minus 1. Okay, so same deal here. I want you to find p for me. There's only one small difference. What's the small difference? Yeah, instead of saying equal 0, it should equal minus 1 because that's what the remainder is to be. It's to be minus 1. Okay, try this one for me now, please. Tell me what the value of p is. And I'll do it in a moment. P is 5? Yeah. So what you should have 3. Now what do I put in for x? What's x? Minus 3, yeah. Cubed plus 15 minus 3 squared plus 20 minus 3 plus p should equal minus 1. Yes, you have that? Yep. So you get p equals minus 1 plus 60 minus 9 times 15 plus 81, I think. And what does this work out as? Is that right? Because
It's -6 plus b.
negative 6?
Negative plus b equals to minus 1.
Yeah, what's the total here for p?
Minus 5.
Minus 5. Does that all add up to minus 5?
Plus 1.
It's plus 5? And you got it as plus 5? And does mine work out as plus 5? Please check.
It does. The whole thing is -6 plus b equals
It's negative 6 plus b equals negative 1. 6 other side is 5 minus 1 is 5.
Wait, slow down. Mine works out as 5. And what did you get? 5. And the answer is 6.
What?
It's a troll.
It's a troll question.
The answer is 6.
3x cubed plus 15x squared plus 20x plus p divided by x plus 3 4c.
Yes, answer is 5.
Did everybody get 5?
Yep.
Alright, the answer must be wrong then. Yeah. So just change the answer at the back for that one. That was actually, as long as I wrote it down right, that was 4c. 3x cubed plus 15x squared plus 20x plus p. I wonder if it was a typo, if I meant to type +1 in the question. Anyways, can I go on to a more difficult example now?
Yes, please.
Yep. Okay. I say px cubed plus 17x squared minus 15x plus q. This has two factors.
Yes, plus 4 plus 9 cube.
Factors are 3x plus 4 and 2x minus 3. That's it. That's it. Yeah, yeah. You have to substitute twice.
To get the first equation and then
That's it, to get a first and a second equation. So in the first factor, what do I use for x? Minus
minus
4 over 3. And in this one,
it's 3 over 2.
3 over 2. And what should the answer be when I substitute them?
0.
0.
Because they're
Yeah,
factors.
because they're factors. Yeah, because they're factors. Okay, so the first one, p minus 4 over 3 cubed plus 17 minus 4 over 3 squared minus 15 minus 4 over 3 plus q should equal, what should it equal here? 0. Is this minus 64 over 3? You have calculators. Is this minus 64 over 3? Yes? Yes? Yes. Okay. And then this is 16 over 9 times 17. What's that, please? Yep. So whoever said yes, 27, of course. Thank you. And the next one? What's this one? 272 over 9. Okay. Now this one be positive, and then is it 20? Double check, please. Is it 20? Okay. If I want to get rid of the fraction, I should multiply everything by 27. Sorry, now that's a 9, not a Q. But I won't bother. I'll just leave it like this for the moment, except I can put these two together. So when you add these together, what do you get? Can you add the middle two for me, please? These two here. What is it? So minus 452 over 9 when I take it to the other side. Okay. 452. 452. Okay, and then here, P plus Q. Okay, now I need to put the other one in. So that's actually, as someone said, our first equation. We can't actually find P and Q yet because we only have one equation, but we have two unknowns, so that's our first one here. Okay, so next, what do we put in next? 3 over 2. So P times 3 over 2 squared plus 17 times 3 over 2 squared minus 15 times 3 over 2 plus Q. That's a cubed. (27 over 8) is it? 9. 27 over 8? 27 over 8 P. Okay, so what's this next one? 153 over 4. Okay, the next one is minus 45 over 2 plus Q equals 0, isn't it? Yes. Yeah. Can you add again the middle two together, please? Well, yeah, subtract them. So what did you get? So it'll be minus 63 over 4 here. Okay, so you have 27 over 8P plus Q equals that. So now I have two equations with two unknowns. So what should I do next if I want to find P and Q? Yeah, I have a few methods, don't I? What's graphical elimination, substitution, matrix, Gaussian. So what would be the best method to use here? Elimination. Why? The Q's are all ready to cancel. Okay, so if I subtract, now you need to do I'll do the top minus the bottom. Minus 64 over 27 minus 27 over 8. What's that, please? Should be negative also.
Minus 1079 over
1079 over 168p. Now, minus these, subtract these, but just be careful, minus minus. So it's actually plus there.
minus 1241 over 36.
Over
36.
problem, Hussein?
Yeah.
What?
So you minus those two.
Yeah.
And then you got minus.
And I got this result here. Yeah. Now, I can finish, the two minuses cancel, so I get P would equal 1, nice, and as 6, is it? It will be that number divided by that number. And you said, Tanish, that works out as So, of course, such a nice number must be right. Yeah. 6. And then how can I get the q? Sub it back in here. So I get q equals minus 63 over 4 minus 27 over 8 times 6. What's that? What is it, Luke? Minus 36. No. Question.
Just divide that, you got 6.
Just type that into the calculator and I got minus 36. What are you asking me?
Yeah, you just replace the 6 into that.
Yeah, replace it into this one, yeah. Or, I mean, it could have been the first one as well, yeah. Just like when we did the degree 2 systems.
Oh, yeah.
Yeah. Oh, hang on. Oh, you're talking about back up there?
Everything was wrong.
You told me they got 6.
Nothing is permitted.
It's next to 36.
Then each country for 1.
Is it? You got 6?
It's 6 with negative.
Yeah, it's 15 wrong. 15 is supposed to be this, but
Oh. So you told me, didn't you? So hang on, we'll fix it now. Hey, look up. Calculator error. Right, how far back do I need to go?
yes, 15 talks there.
Oh, here.
Yeah,
So this one here.
yeah,
Here.
yeah, 15.
Here.
Yeah,
Yeah, what's P?
it's supposed to be minus 1241 and we're 216.
Yeah.
Oh.
1, 2, 4, 1, 2.
No, the answer is correct.
The answer is going to still be 6.
Right, so which number needs to change? Just read out the number that's wrong.
The P to
No, I just want to hear a number.
Negative 979 over 168.
Thank you. Okay, that should have been
1241.
1241 over
216.
minus 1241 over
216.
216.
216. So change that and that, but this still worked out as 6 because someone used the right number. Okay, that's great. So then this is still minus 36. Okay. Those two numbers I circled in red, just replace them with this number. Now, here we have P and Q. I'll scroll back down, but I just want to go back to the question up the top. Hey, look up, Hussein. You see that cubic up there? We now know P and Q, yeah? And we actually have two of the factors. What were the two factors that I say?
3 over 2 and negative.
Well, as factors, 3x plus 4 and 2x minus 3. Now this I said is normally a section B question, so it'll have more parts. So what do you think the next part of the question might be? So you just found P and Q, so you know the cubic, and you know two of the factors. So what might be the next thing they could ask you to do?
Find that.
Well, be more specific. Not quite, no. Not quite.
Sketch.
Well, hang on. How many factorize? How many factors do we have? And how many are there? 3. So the next part of the question could be find the other factor. Good. And then after that, now that you have all 3 factors, what can you do with factors?
Sketch.
Yeah, you could solve for x and then sketch. Yes? Yes, painful.
What if you made a mistake at the top?
The error doesn't carry down in the marks. So,
3 or 4 lessons in one question.
what's that?
It's like multiple lessons in one question.
Yes. Yeah, well, that's what the section B questions are like. Like one section B question is supposed to be like a full chapter. So this covers a few things. And then drawn the graph. But we haven't done the graph of this yet. Yes? I'm telling you, I've seen this in section B in the exam a few times. And then you know the ones where we just have to find one number, like the P? That would be more suitable for section A. Okay, so this is the remainder theorem. Now, which one's the try? Okay, highlighter. You all noticed it was a lot harder without Tal, didn't you? Yeah? All right. Okay, so from number 1, F and G. Number 2, F and G.
G and H.
Yes, G and H in the next one.
C, T.
Now, hang on.
R, S. T.
Not R, no.
K,
K, L, M, N, O, P, Q, R.
You don't know which ones I'm looking for. I want one with a remainder and with... Okay.
L.
GH, yes.
Again?
GH. No, and then for the last one...
D and H.
No.
H.
H and I. Wait, now before you start, tell me what's different about I compared to what I just did.
I have a remainder.
It has remainders.
Two remainders.
So you just
So instead of the equal 0, it's equal 9 and equals minus 363. There are 2 remainders. Yeah. Yeah. It's okay?
Yep.
Alright, you can start them now. So get started. You've got 5 whole minutes. Get started.
Come on.
Yes.
I didn't understand what's the objective of
Yes?
yeah.
I'll come down and help you then.
See, the more complex it is, the easier it gets.
I just like
You ask him, and they say, yeah,
It's a fact.
you press it, yeah.